Hello and welcome back to the course on machine learning. In today's tutorial, we're going to talk about the k-nearest neighbors algorithm. All right, so let's get started. So let's imagine that we have a scenario where we have two categories already present in our dataset. So we've identified two categories, and one is category 1 on the left, which is red. Category 2 is green on the right. And for simplicity's sake, we're just going to take into consideration two variables or two columns in our dataset. So all of this grouping is happening based on these two columns, x1 and x2. And now let's say we add a new data point into our dataset. The question is, should it fall into the red category or should it fall into the green category? How do we decide that? So how do we classify this new data point? Do we classify it as a red data point or a green data point? And that's where the k-nearest neighbors algorithm will come to assist us. At the end of performing this algorithm, we'll be able to identify whether it's a red or green point, and in this case, the point turned out to be red. So how does the k-nearest neighbor algorithm work? How did it do that? Well, we're going to build a step-by-step rule guide to the KNN, and after we've built it, we're going to actually perform it manually to see how it works. And as you'll see, it's a very, very simple algorithm. All right, so the first step is to choose the number k of neighbors that you're going to have in your algorithm. So you have to identify whether k is equal to 1, to 2, 3, 5, or some other number. And one of the most common default values for k is 5. And next, you need to take the k-nearest neighbors of the new data point according to their Euclidean distance. Now here, you don't have to use Euclidean distance. You can use other distances, such as the Manhattan distance or any other distances that you might be considering. But in most cases, the Euclidean distances are used, so we're going to stick to those. So once you've taken the nearest neighbors, among these k neighbors, you need to count the number of data points in each category. So how many data points fell into one category, into the other category, and so on. If you might even have more than two categories in your data set, so you just need to calculate how many fall into which category. And then you need to assign the new data point to the category where you counted the most neighbors. As simple as that. That's why it's called k-nearest neighbors, and then your model is ready. As you can see, it's a very simple algorithm, and moreover, we're just going to do a manual exercise right now to really solidify this knowledge. So let's move on to that. So here we've got the new data point has been added to our scatter plot as we saw previously. How do we find the nearest neighbors of this new data point? Well, let's have a look at the Euclidean distance that we're going to use. So Euclidean distance is a very basic type of distance that we define in geometry. It's the one we use in geometry. And basically, if you have 2 points over here, P1 and P2, then the distance between the 2 points is measured according to this formula. So x2 minus x1, the difference between the x coordinates and then squared plus the difference between the y coordinates squared, and then you take a square root out of all of that. And that is basically, if you look at it this way, it's a right angle triangle, and so you're taking one cathetus and you're squaring it, you're taking the other cathetus and you're squaring it, you're adding them up, you're taking the square root, and that gives you the length of the hypotenuse. So there we go. That's how Euclidean distance work. Again, you could choose any type of distance, but this is the geometrical distance, and this is the one we're going to stick to. So basically on a scatter plot, a two-dimensional scatter plot, we can just draw the lines and see what is closer. So here's our new data point. How are we going to identify which are the closest 5 neighbors? So basically, we just look at them and we see the distances here. So we can see that's the closest one. That's probably the second closest one, third closest, fourth closest, fifth closest. So let's outline those. There we go. So now all we have to do is step 3, among these k neighbors, count the number of data points in each category. You can see in category 1, in the red one, we have 3 neighbors. In category 2, we have 2 neighbors. So therefore, step 4, assign the new data point to the category where you counted the most neighbors. That means we need to assign it to the red category. As simple as that. There we go. Now we have classified this new point and your model is ready. There we go. It's a very straightforward algorithm, one of the simplest you can think about it. So it's very good to get this section started with a simple example like that. And also we're going to have a look at some practical exercises, and Hadlin will show you around R and Python. I look forward to seeing you next time, and until then, enjoy machine learning.